Welcome to my new video, Introduction to Game Concurrency. What is concurrency? In this video, we will talk about the concurrency. Introduction to subprogram level concurrency, semaphores, monitor, message passing, Java threads. Concurrency can occur at 4 levels: machine instruction level, high level language statement level, unit level, program level. Because there are no language issues in instruction and program level concurrency, they are not addressed here. Categories of concurrency: physical concurrency, multiple independent processors, logical concurrency. The appearance of physical concurrency is presented by time sharing one processor. Software can be designed as if there were multiple threads of control. A thread of a control in a program is the sequence of control a program point reached as control flows through the program. Category concurrentize quasi concurrency have a single thread of control. A task or process is a program unit that can be in concurrent execution with other program units. Tasks differ from ordinary subprogram in that a task may be implicitly started when a program unit start the execution of a task. It is not necessarily suspended when a task execution is completed. Control may not return to the caller. Tasks usually work together. Heavyweight tasks execute in their own address space. Lightweight tasks all done in the same address space. A task is disjoint if it does not communicate with or affect the execution of any other task in the program in any way. Task synchronization, a mechanism that controls the order in which tasks execute. Two kinds of synchronization: cooperation synchronization, competition synchronization. Task communication is necessary for synchronization provided by the shared non-local variables, parameter, message passing. Kinds of synchronization and cooperation: task A must wait for task B to complete some specific activity before task A can continue its execution. The producer consumer problem competition: two or more tasks must use same resources that cannot be simultaneously used. A shared counter. Competition usually provided by the mutually exclusive access. Approaches are discussed later. Need for the competition synchronization: you can see the value total 3: task A, task B, task C. Fetch, total, add one, store. You can see at a time they are used one of resources. Not all the tasks are using the resources at the same time. Scheduler. Providing synchronization required a mechanism for the delaying task execution. Task execution control is maintained by a program called the scheduler, which map task execution on the variable processor. Task execution states: new, created but not yet started, ready not run but currently running, available running, blocked, has been running but cannot now continue, usually waiting for some event occur, dead, no longer active in any sense. Liveness and deadlock. Liveness is a characteristic that a program unit may or may not have. In sequential code, it means the unit will eventually complete its execution. It can concurrent environment, a task can easily lose its liveness. If all tasks in a concurrent environment lose their liveness, it is called deadlock. Method of providing synchronization: Semaphores monitors message passing. What is semaphores? Force. Dijkstra in 1965. According to this, semaphore is a data structure consisting of a counter and a queue. For storing task descriptors, semaphores can be used in implementation guard on the code that access shared data and structures. Semaphores have only two operations: wait and release, originally called P and V by the Dijkstra. Next one is example is shared buffer used to semaphores for the corporation, empty spots and full spots. The semaphore counters are used to store the numbers of empty spot and the full spot in the buffer. The buffer is implemented as an ADT with the operator deposit and fetch as the only ways to access the buffer. Deposit must first check semaphores to see if there is a room in the buffer. If there is a room, the counter of the info stored is decremented and the value is inserted. If there is no room, the color is stored in the queue of info spot. When deposit is finished, it must be increment the counter of the full spots. Fetch. Fetch first to check the full spot to see that there is a value. If there is a full spot value, the counter of the full spot is decremented. The value is removed. If there is no value in the buffer, the color must be placed in the queue of the full spots. When fetch is finished, it increments the counter of the info spots. The operation of the fetch and deposit on the semaphores are accomplished through two semaphores operation named wait and release. You can see the code wait operation. Wait semaphores. If semaphores counter less than 0, then decrement semaphores counter else. Another is the release. You can see the code. I will share the slide in my bottom link. You can download and read out. Producer consumer code. See the task consumer loop, wait, fetch, release and loop. Thank you for watching. In next video I will tell you more. Thank you for watching. Like and subscribe.